Okay, in this video, I want to consider this system of linear equations: x plus 5y is equal to 12, 3x minus b times y is equal to 0, where b is a constant. And I want to know for what values of b does this system have no solution? Meaning there's infinitely many values I could plug in for b, but for what particular values of b could I choose such that if I try to solve this system, I would end up with no solution? And I'm going to approach this from three different ways. One is first graphically or intuitively. The second is from using substitution. And the third is from using elimination. Basically all the different methods that we use to solve systems. Under the first method, we recognize that a system of two linear equations just like this, they have no solution if the lines that they represent, here I'll call this equation 1 and equation 2. If we graph the line given by equation 1 and then we graph the line given by equation 2, and we realize they're parallel lines, they look something like this, then they have no solution, right? Because the intersection where these two lines meet are the solutions of the system. And if they don't intersect anywhere, in other words, they're parallel, I should say they're parallel and non-overlapping, right? You could have one line here and one line right on top of it. Those are parallel, but they're overlapping each other. In that case, there'll be infinite solutions. But anyhow, so if they're parallel and they are not overlapping, then there'll be no solution. And what is the criteria for that? Well, parallel, what that really means is that they have equal slope and different or unequal y-intercepts. Right, so I'm going to convert these two equations into slope intercept form. The first one, subtracting x from both sides and then dividing 5 on both sides, we get y is negative a fifth times x plus 12 over 5. And from the second equation, we get, well, here's the first equation. From the second equation, if you rearrange it, solve for y, you're going to end up with y is 3 over b times x. Now, I wrote the 3 over b in the front because I want to know that that's the slope, right? The b in here is not a variable, but it's a constant. So in other words, the slope of the first equation is 1 negative a fifth. The slope of the second equation is 3 over b. Now, the y-intercepts are clearly different, right? One is 12 over 5, and the other one is 0. And b value is not going to affect the y-intercept, as you can see. But if we have equal slopes, well, to have equal slopes, negative 1/5 would have to be equal to 3 over b. And now, what value of b would make this equation true? Well, we solve for b here, and whatever method you like, you're going to see, like cross multiply by b on both sides, whatever you like, you're going to see that b is equal to negative 15. And indeed, this is the right answer. If b is negative 15, then these slopes will be equal. They'll both be negative a fifth. And the y-intercepts will be different. And so these lines will be parallel, but not intersect, not overlapping. And so there'll be no solution. So that's the first method. And then I'm going to try using substitution next. And you're going to see we're going to end up with the same answer. So again, let's take our equations here. And actually, we solve for y in terms of x in the second equation already. Y is 3 over b times x. And we know that using substitution, we can plug this back in, this expression, in for y in the first equation, and then solve for x then. So let's see what we get here. X plus 5 times 3 over b times x is equal to 12. And then we want to know what values of b would make this equation have no solution. Now recall equations that have no solution if we're just given all numbers, right? We have no b value. We're just solving a system and then it ends up having no solution. What ends up happening is we end up with 0 on the left-hand side and some number, in this case it'll be 12, on the right-hand side. Right? We have a false statement, a statement that 0 equals 12, which is false. And so we're really asking what value of b would make it so that the left-hand side goes to 0. Or in other words, that this term perfectly cancels out this term, the x term. You can think of it as, if we collect like terms here, we get 1 plus, well, we get 15 over b, because the 3 times 5 is 15. times x is equal to 12. In other words, what value b would make the left-hand side 0? In this case, that we would require this to be 0. And so in other words, 1 plus 15 over b is 0. And again, if you solve that, you're going to get negative 15. And again, try plugging in negative 15 into the in for b right here. You're going to see that the left-hand side evaluates 0, and so we get 0 equals 12, and so our system has no solution. And now finally, using elimination. So again, let me write the two equations here. We have x plus 5y is equal to 12. And then we have 3x minus b times y is equal to 0. And now let's say I want to eliminate the x variable to solve this. So what I would do is I would take negative 3 times the first equation and add that to the second equation. That way I have a negative 3 here multiplied by negative 3. 5 times negative 3 is negative 15. And then negative 3 on the right-hand side, multiply by that, I get negative 36. And then when I add these two together, you can see the x terms cancel out. The negative 3 and the 3 cancel out. And so I end up with, well, if I have negative 15y minus b times y. On the right-hand side, I get negative 36. Notice that both these terms have a common factor of y, so I can factor out the y here. And so I end up with negative 15 minus b times y. And again, when we eliminate and we end up with no solution, what ends up happening is the left-hand side is equal to 0, and the right-hand side is equal to some other number, like negative 36. In other words, when we eliminate x, we also eliminated y in the process, and the right-hand side is not 0, so it's some other number, right? Like negative 36, 5, whatever you end up getting. And so again, we ask ourselves, what value of b would make the left-hand side 0? And again, it's when this constant, or this number being multiplied by y is 0, right? If this is 0, then 0 times y is 0, of course. And of course, what value, if I set this equal to 0, what value b works here? Well, again, b is negative 15. So I encountered this problem from three different perspectives. One, looking geometrically, looking at parallel lines, and what a system having no solution means that the lines are parallel and non-overlapping. In the second case, I looked at substitution. I solved for y in terms of x in one of the equations, and I plugged it in for y in the other equation, and see what values of b would make the typical no solution case where we have a false statement. Similarly with elimination, I eliminated the variable. Here I chose to eliminate x, and I actually could have eliminated y, which I'll actually go through in a second here. But I eliminated x, and then I asked myself what value of b would make the left-hand side equal to 0. In other words, what value of b would make it so that I cancel out the y variable as well as the x variable. Right? Normally when we do elimination, we want to only cancel out one variable. But if the other variable cancels out and we end up with a false statement, like 0 is equal to negative 36, then the system has no solution. So that's pretty much it. But let's go a little bit further here. Let's take x plus 5. Here's our original equation. What is it? 12, right? And the other equation, which is 3x minus b times y, is equal to 0. Let's say I want to eliminate y, which we can also do, and it will also work. What would we have to do? Well, we'd have to multiply the first equation by b. Let's multiply the first equation by b. And the second equation by 5. 5 times the second equation. And so in the first equation, if I multiply by b here, I multiply by b, 12b. In the second equation, I multiply by 5, so this becomes a 15x. Multiply by 5 here, so it becomes 5b. And on the right side, 0 is still 0. And then when I add these together, you can see that the y terms will cancel out. And the x terms will get bx plus 15x. 15x is equal to 12b. And you can see on the left-hand side, it is x in both terms, so I can factor it out to get b plus 15 all times x is equal to 12b. And again, we actually ask ourselves what value of x would make the left-hand side cancel each other out. And that would be, again, when b plus 15 is equal to 0. In other words, b is equal to negative 15. So again, I encountered this problem, and I tried all these different methods. As you can see, all methods give us the same result. And just as an aside, this is one of the great things about math, is that if you know the methods work, and all of the math is well thought out, then no matter what technique you use, as long as it's a valid technique, you will get the right answer. That's it for this video. If you found this video interesting or it helped you understand systems of equations, feel free to like, comment, and subscribe, and check out my other math videos on my channel.